All right, everyone, welcome back. We're diving into something pretty fundamental in Python today, checking the type of a variable.
Yeah, this is a good one.
You might think, oh, okay, this sounds pretty basic,
Right.
But trust me, this is a skill that can really step up your coding.
Yeah, it can make a difference between code that works and code that's like truly robust and reliable. Like you can really depend on it.
Exactly. We've got a bunch of sources here that break down three main ways to do it. We've got the type function.
Yep.
The instance function,
Uh-huh.
and then just some strategies for handling custom classes,
Right.
which we all, we love to create our own custom classes.
Of course, yeah. Everyone loves custom classes.
So we'll kind of dig into why knowing these methods is like a secret weapon in your Python arsenal for cleaner code, more bug-free code, all that good stuff.
Absolutely. It's like having X-ray vision for your variables. You can see right through them and know what's going on and avoid those nasty surprises later.
Okay, so let's start with the type function. Seems pretty straightforward, right?
Yeah.
You use it to find out the type of a variable.
Straightforward?
Is it really that simple?
On the surface, yeah, absolutely. It's your quick and dirty check. You just pass in a variable and boom, type tells you, is it an integer? Is it a string? Is it a list? Whatever it may be.
So if I have a variable called age
Okay.
and set it to 30,
Right.
type age would just spit back integer.
You got it.
Okay, so simple enough.
Yeah.
But here's where I think it gets interesting. Let's say you're working on a project and you have a more complex class hierarchy.
Okay. Yeah.
Type only looks at the immediate type right.
That's right.
It doesn't consider inheritance,
Exactly.
which can lead to some sticky situations.
You can get into trouble, for sure.
So, okay, hold on. Inheritance.
Right.
For those who might need a refresher, what is that?
Inheritance is like a family tree for your code. So
Oh.
you might have a very general class, let's just call it animal, and then more specific classes like dog, cat, that inherit characteristics from that animal class type would only be able to tell you if something is a dog. It wouldn't be able to recognize that it's also an animal.
Okay.
Does that make sense?
I see. So press it gives you the specific model of the car,
Okay.
but instance tells you it's also a vehicle.
Yeah, exactly. Like
Yes.
a broader categorization.
And that's important because
That's important because in complex programs, you often need to know if an object belongs to a broader category. So let's say you have a function that's supposed to work on all animals.
okay.
Using type to check if something's a dog wouldn't guarantee that it would work.
Interesting.
But isinstance would catch that, oh, it's part of the animal family, so this function should apply.
Okay, that makes a lot of sense.
Yeah.
So isinstance is like that friend who always sees the bigger picture.
Yes. Okay, cool. It's essential for object-oriented programming, where, understanding the relationships between classes is crucial. And it's not just limited to single checks either. You can use isinstance with a tuple to see if something belongs to like a group of types.
A tuple. So you mean like checking if something is either a string or an integer.
Precisely. Let's say you're processing user input, You could use instance to verify if that input is either a string or an integer, giving you more flexibility in handling different data types.
Okay, so isinstance is sounding pretty powerful. It's like the Swiss Army knife of type checking.
It's pretty versatile, yeah.
What else can it do?
Well, it's particularly useful when you're working with lists. So imagine you have a function that's expecting a list as input.
Okay.
Isinstance can quickly confirm, is the variable you're passing in actually a list?
Okay.
And this prevents potential errors down the line.
So if I accidentally passed a single number to that function instead of a list,
Yeah.
isinstance would raise a red flag and be like, whoa, hold on.
Exactly. It helps ensure that your code is behaving as expected, which is crucial when you're building larger, more complex applications.
This is already making me rethink how I approach type checking in my own projects. I'm starting to see why it's more than just a basic concept.
Yeah, it's about writing code that's not just functional, but it's resilient, it's maintainable.
Right, yeah. It's got to be able to stand the test of time.
Exactly.
And different developers coming in and all that.
Right.
Okay, cool. So we've covered type.
Yep.
We've covered isinstance.
Uh-huh.
What about custom classes?
That's where things get really fun. Let's dig into that.
All right, let's do it.
Okay.
Okay, so we've covered type for those quick checks and isinstance for when inheritance comes into play.
Right.
It's amazing how much depth there is to something that seems so simple at first.
Yeah.
But what about when we venture into the land of custom classes?
Oh, yeah.
Do these type checking methods still apply?
Absolutely. In fact, they become even more crucial, I would say. When you're designing your own classes, you're essentially creating your own blueprints for data.
Okay.
And just like a good architect, You want to make sure that those blueprints are solid.
Right. So how does type checking fit into this whole blueprints analogy?
So imagine you've designed a class called car, right?
Okay.
And it has a method to calculate fuel efficiency.
Okay.
You wouldn't want someone accidentally passing in the car's color instead of its mileage. Right.
Yeah, that would lead to some pretty wild calculations.
Exactly.
So type checking is like making sure you're using the right materials in the right places when you're building that car.
Exactly. It's about ensuring that the data flowing through your custom classes is what you expect it to be. Let me give you a more concrete example. Remember that person class from our source material?
Yeah, the one with just the name attribute.
Right. But let's say you added a method to calculate that person's age based on their birth year. You'd want to make sure that the input for the birth year is actually an integer, right?
Otherwise, you might end up with someone being born in the year 20.23.
Exactly. Not quite accurate.
So you could use isinstance within that method to validate the input type. If it's not an integer, you can either raise an error or handle it gracefully, preventing unexpected behavior.
So it's like adding a safety check to make sure we're not mixing apples and oranges, or in this case, birth years and strings.
You got it. And this kind of type validation becomes especially important as your classes get more complex and interact with each other. It helps prevent those subtle bugs that can be a real headache to track down.
I can definitely relate to that. Now, our sources also mention some more advanced tools like abstract base classes and the collections.abc module.
Yeah.
Are those something we should be using for type checking in custom classes?
Those are definitely worth exploring as you level up your Python skills. Think of them as specialized tools for specific scenarios. Abstract base classes, or ABCs, provide a way to define interfaces for your classes.
Interfaces. So it's like setting rules for how different parts of the code should interact. Precisely. Let's say you're building a system with different types of vehicles. Cars, trucks, motorcycles.
Okay.
An ABC for vehicle could specify that all vehicles must have a start engine method, ensuring consistency across your classes.
That makes sense. So it's like creating a common language for all those different types of vehicles to communicate.
Exactly. And the collections.abc module provides a bunch of pre-built ABCs for common data structures like lists, dictionaries, and sets. This can be incredibly useful when you're working with collections of data and want to enforce specific behavior.
Okay, so give me an example of how I might use collections.abc in a real project.
Let's say you're writing a function that needs to process any type of iterable, whether it's a list, a tuple, or even a custom iterator. Using collections.abc.iterable as a type check ensures that your function will work correctly regardless of the specific iterable type.
So it's like saying, I don't care what kind of container you are as long as you can be iterated over.
Exactly. It gives you more flexibility and makes your code more robust because you're not relying on specific types.
This is all starting to click for me. It's not just about knowing what type of variable is. It's about understanding the implications of that type and using the right tools to ensure everything works harmoniously.
That's the essence of it. Type checking is a fundamental part of writing clean, maintainable, and most importantly, reliable Python code.
This deep dive has really opened my eyes to the importance of type checking in Python. It's gone from seeming like a simple concept to like a powerful tool for building better code, more reliable code.
It's one of those things that can really take your Python skills to the next level, you know. And the best part is it's not just about avoiding errors. It's about thinking more deeply about how your code works and how different parts kind of interact.
Absolutely. So for those listening who are ready to go out and apply this stuff, what are the key takeaways?
Well, we started with the type function, which is great for those quick checks when you just need to know the basic type of a variable. But we quickly realized its limitations when it comes to inheritance.
Right. Type is like a quick glance and this instance is deep dive.
Exactly. Isinstance is your go-to when you're dealing with object-oriented programming, and you really need to consider those relationships between classes. A dog is not only a dog, but also an animal.
And that can make such a difference in how your code actually behaves, especially in larger projects.
Absolutely. And then we explored the world of custom classes, where you, as the developer, you have the power to define your own data types and enforce type checking to make sure everything works the way you want it to.
It's like building your own set of rules for how data should flow through your code. And we even touched upon some more advanced tools like abstract base classes and the collections.abc module.
Right. Those are definitely worth exploring for anyone who wants to take their type checking to the next level. They provide a way to define interfaces and work with collections in a more robust and flexible way.
Thinking back on your coding journey, was there like a specific moment when the importance of type checking clicks for you?
You know, I remember working on this project where we were handling a lot of user input, and we were initially relying on type checks. We kept running into these weird edge cases where the code would just behave so unpredictably. It was really frustrating.
Oh, man.
And we finally realized that we needed to use instance to account for all the different ways that users could be providing data. And once we made that switch, a lot of those kind of mysterious bugs just vanished.
That's a perfect example of how understanding these nuances can save you so much time and headache down the line.
Oh, yeah, for sure.
So as we wrap up this deep dive, what's like one key piece of advice you would give to someone who wants to get better at type checking in their Python code?
I would say don't be afraid to experiment. Try out the different methods we've talked about, see how they fit into your workflow. And most importantly, don't think of type checking as this like chore. It's really a way to improve the quality of your code, to make it more reliable.
Yeah, to make it more robust, more maintainable, and ultimately more enjoyable to work with.
Exactly. And who knows, you might even discover some new techniques and best practices along the way.
That's the beauty of coding, right? There's always something new to learn. Well, on that note, we've reached the end of our deep dive into Python type checking. Hopefully you've all learned some valuable insights and are feeling inspired to level up your coding game.
Happy coding, everyone.